Okay, so as I was just saying, when you have the lower bound, imagine if it's switched around and the lower bound is in the reverse spot from the upper bound. We're going to change it to a negative and switch it.
If the lower,
Like A is less than B. Oops. Let me. Right here. A has to be less than B, and B is less than C. So imagine if the lower bound is actually the bigger number.
oh, okay.
That's what I'm saying. The bottom number should be smaller. So I gave the example of 3 to 0. So when the bottom number is really larger, we want to switch it, make it negative, and switch the bounds. Okay? Next, what if our bounds are the same? So remember, if you're looking at area under the curve, so let's say you have some function, and you're looking at from 4 to 4. Well, there's no area under the curve if it hasn't gone anywhere. So remember,
If the numbers are the same.
yeah, when the numbers are the same, the integral is automatically going to be 0 here. Okay?
It's easy.
Still come up? 6.
All right, next one. What happened to what? Something else not related to this.
Hi, Maya.
I bet.
It's so much more efficient when they're not here.
They know you're there.
Wait, oh yeah, Ben Glader's not here. No wonder. it's
Do you
so
want to
quiet.
just get it out of your system right now? Hello?
Yeah,
it's so easy.
Hope you're having
Andrew, go.
fun. I miss you. Hope you feel better. I don't know if somebody's sick.
No, they're all in the Spanish field trip.
Oh, hope you're having fun.
Adios.
Hola.
We love you all.
Okay.
Ben has Ebola.
He has a mild case of Ebola.
Guys,
It's
I don't know, Mr. Romero?
Okay,
You can walk it.
Oh my God, let us learn. God,
Okay.
it's like a semester.
no excuse. It's still calculus. All right, moving along.
So,
So the next one, K is basically a coefficient. So if I have, let's say from, doesn't really matter what the bounds are. Let's say I have 3 times f of x. That 3 can go out in front. So in other words, you could figure out the area under the curve of f of x and then just multiply by 3. The same thing is true for derivatives. It just makes it easier if you take the antiderivative, like if you figure out
what's
the
the
area
number that comes before the variable?
coefficient.
The
Yeah.
coefficient basically just comes to the way front.
Right. You can just move it to the front. It's kind of like when you do derivatives. You can do the derivative and then multiply by the coefficient. Sum and difference. This is it's kind of like distributing the integral sign. So if you have from let's say from 0 to 5, let's say I have x squared plus 2x. I can rewrite this as from 0 to 5 of x squared and from 0 to 5 of 2x. It's like I distribute the integral sign to each part. Sometimes it makes it easier, sometimes it doesn't. Just showing that you can distribute that integral sign.
I believe it is.
Is this the whole lesson?
No, this is a very long one. Okay,
Wait, so this isn't gonna be on the quiz, right?
yes.
Wait,
Okay,
it's
so
actually- this is gonna be on the
activity.
Wait, it is on the quiz? No.
Yes.
Next one.
Hold on.
So let's say I have from 0 to 2 of f of x dx. And let's say I have from 2 to 5 of f of x dx. We can combine these into one integral. So notice, imagine that you had a graph. Doesn't really matter what the graph looks like. But if I have a graph, right, here's 2, here's 5. So if I know the area under the curve from 0 to 2, and I know the area under the curve from 2 to 5, then I know the area under the curve from the
Zero to
whole
five.
thing, from 0 to 5.
Of course.
That's additivity.
So,
So, what we need to make sure is that this, and this are the same. Basically, the upper bound for the first one and the lower bound for the second have to match, and then it's kind of like you put the 0 and the 5 together. Like wherever they went from 0 to 2, and then it's going to pick up back here at 2 to 5, and then you have the whole thing from 0 to 5.
Where are you getting those numbers from?
And these are just these are examples. This this
because-
last column is just examples.
Okay.
Because you have to be able to apply the rules for the antiderivatives before we actually know how to find the antiderivative.
I don't know.
You need to know how to do the rules first, and then I'll show you some other formulas.
I just got confused. But I
Oh.
got D, then I got.
Oh, there might be one or two that are not possible, so you have to be able to recognize where it's not possible.
Oh, then I think D's not.
Does that answer? Okay. So, what do we notice about this one? The lower bound is not actually lower. So that's the first rule.
So it's negative.
Right, so we're going to put a negative. We're going to switch this from 1 to 4 of f of x dx. So whenever you see that the lower bound is not the smaller number, we can switch it and make it negative. And then if we look at from 1 to 4, so that's right here. The integral from 1 to 4 of f of x dx is negative 2. So it's going to be the opposite of negative 2, 2. All right, next one. From negative 1 to 4. Now, I have from negative 1 to 1, and I have from 1 to 4.
All that's integral 5
What did negative 1 be on top?
So if I actually combine these two, I'll have the entire area under the curve from negative 1 to 4. Notice that this upper bound and this lower bound have to be the same in order to be able to combine them.
Wait, can you explain why you did that?
Isn't it
Okay,
already combined?
if you look at your information up here,
Oh, I think I see.
you don't know what negative 1 to 4 is, but you have parts of it. You have from negative 1 to 1.
So then
Oh,
one is
wow.
5 and then one is
Five.
negative 2, so then you end up combining them.
Yeah. So one is 5, the other one is negative 2, so you should get 3. Does that make sense? So
It's just plugging it in.
it's kind of like, it's the opposite of what I showed you in the rule. So it's like I gave you from here to here, and I gave you from here to here. So how do you get the whole thing? You add them. So
I don't really understand where you're getting the 5 from.
Look at the,
Is
it's
it-
like up top.
A lesson that changed my life.
okay.
From negative 1 to 1 becomes 5.
I just don't understand where you get the equation.
Okay, so we don't actually know what f of x is. We don't know what they are. We're just using the rules that are in the table above. Which one is going to fit? Like the lower bound, so like this one, we just noticed that the bounds were switched, right? But this one, it's correct. Negative 1 is smaller than 4, so there was nothing really to do here. But I don't have enough, like if I look up here, I don't have anything that says from negative 1 to 4. But I have from negative 1 to 1. So imagine that I had a graph that, what do I want to find negative 1 to 4?
Can I do the second one, please?
So imagine that I want to figure out, let's say I have a graph like this. So from negative 1 to 1, they're saying this area is 5. And then from 1 to 4, this area is negative 2. So if I want to figure out the entire area,
Wow, yes.
the entire, that, does that click?
Can I do this, please?
All right. What's C look like?
Alright, so C would be integral negative 1 to 1, f to the x dx, plus integral negative 1 to 1 h to the x dx.
Okay, so this is the rule where we can distribute
Aren't you proud of me?
with a plus or a minus sign. We have the same bounds, so we're just like distributing the integral to each part. This was the second to the last rule in the table. Okay, so if we look at our table of values, we do know from -1 to 1 of f of x dx is 5. And for h of x, that's 7. So we get 12. Okay, when we get to D, it says from 0 to 1. So if we look back at what we were given, there's nothing that has to do with 0. So this is actually one that there's not enough information here. We don't have enough information. Even though it says from -1 to 1 is 5, it's not like we could just cut that in half and say it's 2.5. Only if it was symmetric, but we don't know that necessarily.
Same.
Right, same idea. We know from -1 to 1 of h of x dx is 7, but we can't double it, okay, unless we knew it was symmetric with respect to the y-axis. So this one's not enough info. And this one,
Distribute the integral.
yeah, so this one, we have 3
I don't even.
times the integral from -1 to 1.
So it's like a parentheses around the whole.
Okay, so the
around
3 is
integral?
just in front of the f of
Oh,
x.
okay.
So only the 3 gets multiplied to the integral of f of x, but the h of x just gets subtracted. But the integral gets distributed to both parts. So what's the integral from -1 to 1 of f of x?
5.
So that's going to be 3 times 5
Oh, I know, it's 15.
minus
7.
7, so we get, okay, questions there? How we got what equation?
I just don't understand how you get the equation. Like, I get that it's a top, but like, you have to look at the equation and examine what situation it is of the top example. No, like, I get that, it's hard for me to see which one.
Is this like this?
If we just learned
Yeah, how are we supposed to study?
Think about the word antiderivative. Anti, it's like
Bad.
the opposite of a derivative. So if I have x squared, what's the derivative of that? 2x.
So the antiderivative of
So
Q
this
is
is
x
what it
squared.
is.
Wait, shh, guys, let her speak.
I'm anti a lot of things. I'm anti-terrorism, I'm anti-child abuse, but I don't know if I'm anti-derivative.
So the derivative of x squared is 2x, which means the antiderivative of 2x is x squared. Now, I'm going to put in here a plus c. The reason I put a plus c is that, okay, when you work, okay, the derivative of x squared is 2x, so this implies that the antiderivative
Why
of
is it
2
the integral sign?
that antiderivative is the integral.
Oh.
Okay.
Oh, that, I see why C's there.
So actually, I'll go if and only if. Okay, so when we work with antiderivatives and we don't have the bounds, we call these indefinite integrals. Okay, so basically indefinite means we don't have any bounds. We don't have an A and a B at the top and the bottom, okay? So if it's indefinite, that means we cannot actually find the exact area under the curve, but we can find a formula for it.
Okay.
Okay, it's kind of like this. Remember when we did derivatives and I said, oh, what's the derivative of x squared? It's
2x.
okay, but where? Don't you have to have an actual point to be able to tell me what the slope is at a specific place on the graph? Right? So you gave me the formula for the derivative, which was 2x, right?
Right.
But if you actually had to find the slope at a particular point, I would have to say, oh, when x equals 3, then you would say, oh, it's 6.
Slope of the tangent.
Right.
Is that what you mean?
So when we're working backwards, you end up with a formula, right? But we can't figure out the actual area under the curve unless we had bounds. So let's say I have x squared. And I said, oh, well, what's the antiderivative of x squared? Well, it goes on forever. Could I ever figure out the area under the curve?
No.
It would be infinity. So what we want to do with antiderivatives is we want to be able to come up with a formula where we do work backwards. But the way that we resolve this is we put in a plus c. So imagine, what's the derivative of this? It's 2x. What happens when you do the derivative of a constant?
1.
Plus one.
Let's try again.
0.
0.
What?
Wait, unless no, it's
Oh,
if it's a
constant.
variable, it's
Zero.
1. If it's a constant,
Oh,
it's
the
0.
constant. Oh.
Yeah.
Oh, wow.
Okay, so just to let you know, all of these,
But math isn't supposed to make sense. Why does C make sense?
C, just remember, if it's indefinite, just put a plus C at the end. That's all you have to do. Okay, if it doesn't make sense, just remember, oh, there's no bounds, I gotta put a plus C. Let me go through.
Yeah,
I highlighted the ones that you have to know.
Alright,
Did you hear that?
I'll highlight that as
I
well.
highlighted the ones that you have to know.
Looks like nothing's
Do we
highlighted.
need to know all of these?
There's only, there's ones below here.
Do we need to know all the ones on this page?
Oh my gosh.
I'm just completely joking. Highlight the one, you need to know the ones I highlighted.
Yes, I need to know, I need you to memorize, not just like be able to plug into our calculator all the formulas. I need you to memorize, like
Cosine's that.
put into your memory. Why? Well, because I have some
Provide
notebook.
all these by tonight?
Okay, no.
Oh, okay.
I will give you till the test to have these memorized. Okay, let me show you how these work.
This is tonight.
Yeah, calculator.
Test is in 5 minutes.
Okay, the first one. Okay, so the way the first one works, I'm going to do like a little example here. Let's say I have to take the integral of x to the third dx. Okay, so when you work backwards, so if you remember with derivatives, we took the exponent to the front, we multiplied it, and then we subtracted by that, subtracted 1. So now we're going to add 1 to the exponent, and we're going to divide by that new exponent. So it becomes x to the 4th over 4 plus c. There's a really easy way to check your answers with antiderivatives. Just do the derivative. If you were to do the derivative of this, you should get back what you started with in the integrand. So if I move the 4 to the front, right, the 4's would cancel, and I get x to the 3rd, and that would, the c would go away.
So
So how do you do that?
example problems of
So you-
the derivative and then we just
Right, so we're working backwards. So whenever you have something to a power, you increase that power by 1 and you divide by that new power. So let's say you have x to the 8th. It would become x to the 9th over 9. What if you had x to the 1/2?
X to the 3 halves over
X to the 3 halves over 3 halves, which would actually be 2/3 x to the 3 halves. What if you had x to the negative 3 power?
X to the negative 2 power.
Good. So if I had x to the negative 3, it would be x to the negative 2 over negative 2.
plus C.
Okay,
On the
so
right, is it saying that x to the 4th over 4, the derivative of that is x to the 3rd?
correct.
Well, it's when you have 4 to the 3rd over 16, which would be x to the 3rd over 4, because you square the
Where are you getting
bottom.
16? I'm sorry.
Because isn't it over the bottom square, or am I thinking of that wrong? I thought it was the bottom times the derivative of the top, and then the top times minus the top times the derivative of the bottom over the bottom square.
Sorry, Luke. I don't know. I'm trying to process what you said, and.
Oh, sure, yours is like blowing apart.
No, I'm actually trying
Wait,
to,
wait,
like,
wait.
follow it logically. Oh, no, don't,
Don't put Andrew.
Just go through this door.
we know how that worked out.
Really? Can
All right, Luke, I'll come back to you. Let me get through the rest of the rules. Okay, add 1, divide by that new power. Now, the only exception is when you have a -1 exponent, because what happens when you do the -1, you would end up with x to the 0 over 0, which is not defined. So that's going to give you ln of the x. We need to put absolute value because we want to make sure that this is a positive number. Yes, I'm positive about that. So, think about the derivative of ln. What's the derivative of ln? 1 over. So 1 over something, the antiderivative will be ln. I know, it's hard because you've been so used to working with derivatives and working one direction, and now we're going the opposite. So,
But life
Do
would
it,
just be,
Andrew.
life would
Do
just be
it.
way too simple if we only went one direction, so. We have to go one direction.
I think I'm anti-antiderivative.
When I think of one direction, I think
That's
of
what
nine.
makes math beautiful.
all right.
Maybe 11.1.
The integral of cosine is sine because the derivative of sine is cosine. The antiderivative for sine is negative cosine because the derivative of negative cosine is sine. The antiderivative for secant squared is tangent because the derivative of tangent is secant squared.
The anti,
These are good to know, but I'm not going to put them. There won't be on your quiz or your
but
test.
isn't the derivative
What's
of
C's
cosine
problem?
negative
Why
sine?
do it straight?
Isn't the derivative of cosine negative sine?
Correct. So the derivative of negative cosine would be negative negative sine.
Gotcha.
Okay, the other one that you do need to know is e to a power. E is probably the easiest one because remember e to a power, the derivative of that was e to the power. Okay, let's look at the examples.
Wait, e to any power is.
Well, not, it's e to the x. If it's e to the 2x, you have to do like a reverse chain rule, but we won't get to that yet. Okay, let's do some practice problems. Okay, it's a power, it's x squared, so it becomes x to the 3rd over 3, and then we just put a plus c because these are all indefinite, so we need that plus c at the end, that's all. Just throw in the plus c. Right. You might want to, yeah, you probably, if you need to flip back and forth, that's fine. What happens when you have cosine?
Negative sign.
Wait, what derivative will give you cosine?
Sine.
Sine. So this is 2 sine x.
Plus c.
Okay. I know, be careful with the sine and cosine because the negative signs are kind of switched from what you were used
I
to.
feel like I just need to take a second and have my brain process going backwards.
That's why I'm not going to have you don't have to memorize these rules for tomorrow. The other ones where we were just adding and subtracting the numbers, yes, but these, you have some time. What's
Yes.
Just equals e to the x.
e to the x?
E to the x over x plus 1.
No, e to the x was just e to the x.
Why?
I don't understand C. Why? What's the point?
Distribute integral.
No, really, what's the point of
She
it?
just said add it. Always add it when it's indefinite.
Can distribute this integral sign to each individual part. That's too much writing. So just do each, and even the coefficients can go out in front. But these are all just the power rule for integrals. So if this is x to the 3rd, it becomes 2x to the 4th over 4. Just bring the 2 along, just like when we did derivatives. The next, we'll simplify in the next step. Next one is going to become 3x to the 3rd over 3. Next one, this is a 1, so it becomes 8x squared over 2. And what do you think happens with the 4?
4x.
4x. Think of this as an x to the 0 power. Really, if you have just like right, if I have 4x to the 0, you would add 1 and divide by it, so it just becomes 4x. and then don't forget the plus c, and we get 1/2 x to the 4th minus x cubed plus 4x squared plus 4x plus c. Again, how can you check your answer?
Do the derivative.
Just do the derivative of that.
And make
So-
sure it equals what you were.
Exactly. I mean, that's the nice thing about integrals is there is a really, I mean, I think relatively easy way just to check your
Whoa.
answer.
So that it's basically finding what the derivative was derived from.
Yes. What the derivative was derived from.
Like what you found the derivative from.
What you found the derivative
Right,
of.
so it's kind of like this is the derivative,
You're trying to
and you're trying to find the original.
I'm liking this.
You got it.
Okay, what's the next one? See, these aren't too bad.
3b.
You're not ahead of yourself.
Not yet. Would it be
3e to the x plus 1
plus
over
2x.
x.
3 to the x plus 2x to the 5th over 5 plus c.
And 2x to the 5th power over 5. I honestly would just leave it like that. All right, next one.
You're not a homework class, you know what I mean?
Hall pass, yes. I would just think of when you see a square root or like a cube root, just rewrite it as a rational exponent. So I have, this becomes 6x squared over 2 minus, okay, so if I add 1 to a half,
3 over
it's
2.
3 over 2. And we don't want to leave complex fractions, so we'll just rewrite this minus 2/3. X to the 3/2 is fine to just leave it like that. Oh, and I almost forgot. Plus c.
I feel like the homework tonight's gonna be very
Oh no.
I don't think so.
Why don't we do it in class?
I have no idea. If we finish, we could probably look at it. But it's x, the integral. I don't think we're gonna finish. That
fraction
really-
thing kind of matters.
X to the
negative
negative
1
1.
over 1. Negative 1.
X to the -1 over
Negative
-1.
plus c.
Oops, that's supposed to be a plus sign.
Then you can just do negative x.
-1 over x plus c.
Okay, I understand why. I understand that you do put plus c, but I understand why you put plus c. So, like, why if it's indefinite, why do you put plus c?
Sign. If you have the integral of negative sign, what is that?
Negative cosine. No,
Okay,
it's
so-
cosine. It's cosine.
What was the integral of sign?
Cosine. Negative.
Negative
cosine.
cosine.
Negative.
So it's cosine.
Can I solve these next ones, please?
Go on the board and do it.
No, please don't.
I think
Please do. Go.
Okay, next one.
You enjoy doing
What do we get?
Oh, that's it?
that? Why do
E to the x
E to the x plus,
plus
okay, now,
x
x to the -2/3. So if we add 1,
to the 1/3 over 1/3. Let's see.
so we want to just rewrite that as e to the x plus
3x.
3x to the 1/3 plus c. And then again, think of this as an x.
This is product rule, right?
No, 4 is just a coefficient, so we don't,
Oh.
it's just going to be 4x to the 3/2 over 3/2. So what does that look like when we simplify it?
8 over
8 over
3.
2.
To the 3/2 plus c.
That's it?
Okay, so we are going to continue.
But
We have 2 more pages to get
it
through.
says that all we're doing today is
Right, because we spent a day doing homework, we now have to do this section in 1 day.
Which one?
Remember how we were supposed to start this section the other day and you guys wanted a homework?
Yeah.
So-
But we were supposed to get today as a free day. We have a review. So we just substituted that.
No, it was supposed to be 5-3 over 2 days.
Oh, well, on the homework thing, it didn't say that. It says a review.
Wait, so are we working on?
No, it says 5-3 continued. See, I think of these things. Mainly because I've taught this for a few years, so I always anticipate that it's going to need more than 1 day. But you guys wanted a day to.
I'd like another day.
So basically, the second day was going to be just these 2 pages of notes, and the rest of it was going to be homework review. Yeah, this is What's left over is actually not that long.
Oh, let's do it right now.
Okay.
Let's
Well,
look
yeah,
at
we
that,
have to.
people.
We don't have a choice because we used the other day. Sorry. Okay.
I mean, we
Um,
don't have to take the quiz tomorrow. That's an option too.
It won't take all periods, so we can review for like 20 minutes and then.
For the vastness.
Okay.
I'm happy with that.
So what if we now have bounds? So whenever you see this capital letter F, this represents the antiderivative of little f. So like when we do the antiderivative of little f, we get big F, capital letter F. Now, when we have the bounds, that now implies that we actually can find the area under the curve. Okay? And the way that we do that is we find the antiderivative and we evaluate it at the upper bound and then subtract, evaluate it at the lower bound. Okay, so let me explain. Okay, take the first example. Just look at the antiderivative of sine x. Don't worry about the 0 and the pi. So what is the formula? Okay, so on that page, what was the antiderivative for sine?
Negative cos.
Negative cosine. So I'm going to put negative cosine. Now there's two ways we can write this. We could either put it in brackets or you can put like an evaluating line. And we're going to put the lower bound here, the upper bound at the top. Okay, so negative cosine x is our capital letter F. So what we want to do is we want to evaluate negative cosine of pi and subtract negative cosine of 0. That's how we evaluate an integral, where we actually have the bounds. So you figure out the formula, and then you put the top bound in, put the bottom bound, and take the difference of the two. Okay?
Can you write it with the integral after?
No. Okay, so once you figure out what this is, you drop the elongated S symbol. You no longer need it. That's why I put brackets around it. So once you actually figure out the formula, you don't put the integral sign anymore. You don't need to rewrite it. Okay, cosine of pi. So think on our unit circle, right here at 0, and here's at pi.
No, so it's 1.
Right, so cosine of pi is -1. So if it's the opposite of -1, it's going to be 1 minus, and then cosine, but it's minus -1.
So it'll be plus 1.
Good. So it'll be 2. What does that mean? That means the area under the sine curve from 0 to pi is equal to 2. Isn't that cool? So we can actually go on our calculator. Did I show you how to check this on your calculator?
No, you should tell us this.
Okay. So, first of all, if you're working with sine cosine, just make sure your calculator's in radians. So, I think I did show you this. If you go to math and then number 9, it shows up with the integral.
Yeah, but what about the TI?
Okay, so yours is going to show up. I'll show you how to type that in.
Tell us the answer.
So, we're going to put in a 0 to pi. And then we put in here sine x. And then dx. Now we get to. You could also go to your graph. Okay, so those of you that have an 83, there's a couple ways you could do it. If you go to your y equals and type in sine x, anybody can do this. All the graphing calculators have this ability. So let's say I'm going to just graph this. I'll just graph it in trig. Okay, so here's our sine curve. If you go to second trace, the calculate button, number 7 has the integral. Is it number 7 on yours also? Okay, so it's going to prompt you for the lower limit. That's your lower bound, which was 0. So just type in 0, enter. and then type in pi. Yeah. And then it's going to shade in the region. And it says it right here, the integral is equal to 2. I just changed it a little bit. Okay, did everybody get that? Oh, for the next one? Or the antiderivative is 2. You got it? Luke. You could also do this. Those of you could do math 9. Those of you with a TI 83, there's a function integrate, and what you do is you type in your sign of x, you put a comma, you put an x, you put a 0, you put a pi, and press enter. That's for the 83 calculators or the older models with the 84. You got 9 for B? Anybody else? Should we try it? Okay, so what's 3x squared? 3x squared, 3x cubed over 3, so x cubed. So here's another way to write the evaluated sign. Like if you just have one term, you just put a line and a little -1 here, a little 2 up here, and that just means evaluated at -1 to 2.
Wait, are you not gonna put the 3 in front of it?
Well, remember, it would be 3x to the third over 3, so the 3's canceled.
Oh, yeah.
So now I'm going to plug in 2, so I have 2 cubed minus -1 cubed. So we get +1, so we get 9. Do you realize what we're doing? Isn't this, we're finding the area under a curve. No? Isn't that neat? Without a calculator. So if I go and I graph 3x squared, guys, I think, tell me this isn't really kind of neat. So,
I really like that your calculator makes that really pretty.
isn't it? But your calculator does it too. It's just, it looks black on yours. So if I go -1, so it figures out the area of the curve, under the curve. Okay, try the next one. And then I do need to get to average value and then we're going to put that.
So wait, can you just explain what can be on the quiz? Like that.
Okay, I will. And I just have to keep going. Do you want to write it for me? Yeah, do you want to put? Did you get one?
Yeah.
Did you get one?
Oh, whoops, I just didn't calculate it.
Okay, go ahead and try the other 2. Yeah, you got 9, right?
So,
I don't know why it's not drawing.
Okay, I get it. There you go.
Come on, look. Come on, look. Come on, look. Mike, look at office.
It's not necessarily saying negative 1.
What? So then it's 1 over x.
Which is 1 over x. Here, he showed it here. Negative x to the negative 1 over negative 1. So the negatives cancel, so it's really just 1 over x evaluated from 1 to 2. So it's going to be 1/2 minus 1 over 1. Do you want me to rewrite it?
Why is it 1/2?
I get
Hey,
the
Andrew,
1 over
I
x.
did-
That's
It's okay. No, I wish it worked that way. It doesn't. Isn't that annoying?
Take off the blindfold. I'm just joking, Andrew. Maybe,
Okay. Quickly, because we have to get through the average value. So, negative. So we have a negative. The negative follows along, right? Negative x to the negative 1 over negative 1. And we want to evaluate this from 1 to 2. So this is really 1 over x evaluated from 1 to 2. Okay. Now we're going to plug in 2. And we're going to subtract, plug in 1.
What the hell?
Question. Remember, do the top bound minus the bottom one. Next one.
Are we ever gonna have these where like it has to do with the at the beginning with all these rules like order?
Not a little bit, but not so much.
Okay.
Okay, what's the antiderivative for secant squared? Well, what derivative?
Oh,
Tangent. We want to evaluate tangent at pi over 4, so tangent of pi over 4 minus tangent of 0.
Why do you split it up?
Which?
Split what up? Oh, yeah.
Last page.
When I grabbed it,
We go to the one thing.
I'll wait, I'll wait.
the graph it didn't work when I grabbed it. It didn't work when I grabbed it.
Did you do 1 over cosine squared?
What over cosine?
I saw that one in the homework.
Okay, average value. When I say average value, this is a y value. So if I give you a graph, we can figure out in a closed interval, we can figure out the average value over a specific interval. Right? So, take this, so let's take a parabola, for example, 4 minus x squared. What's 4 minus x squared look like? Guys, just, come on. 1, 2, 3, 4. It looks like this. Okay? So let's say from 0 to 3.
Like, this is determining the y value?
So, right, so if I'm just looking at the part of the graph, not that color, hold on. Let's say I want to look at from 0 to 3. That's not really drawn to whatever. So if I take a part of the graph over a certain interval, I can figure out the average y value on that curve.
One more time?
But if I have a curve on a closed interval, I can figure out the average y value. So imagine like if you had any kind of polynomial where like let's say you have from here to here, and I say, okay, I want you to take it from here to here, and I figure out the average y value.
Yeah, it has to be like a domain.
Yeah, you have to have,
Like from a value to a value.
right, so here's A and here's B. Okay, so we want to find the average value on this curve.
So for this one, it's gonna end up being like somewhat like.
I mean, it's going to be between there.
Those, it's a little different.
Right. So I'm going to do 1 over 3 minus 0, and then the integral from 0 to 3 of 4 minus x squared dx. And then we can also figure out at what point that would be an x value. So average value is a y value, and then basically at what point this is gonna be your x value. Let's just work on figuring out the integral first, okay? So the 1/3 that you have out in front, just leave that, okay? So leave this as 1/3.
Are we gonna do
Okay, so,
integral of 4 and then
yeah,
integral-
what's the antiderivative of 4? Think 4x to the 0. So it would be 4x. And what about x squared? It's gonna become net minus over 3, good. And we want to evaluate this from 0 to 3. Notice I'm going to use brackets when I have more than one term so I don't get confused here. So I have to plug 3 into both parts, and I have to plug in 0 to both parts. Obviously 0 is going to be easy because, so it's going to be 1/3. So I have, actually let me make that a, so I have 4 times 3 minus 3 to the 3rd over 3.
But this time it's actually
Oh. Let's see.
But this time, if you were to show the work
What about the zero?
it just ends up being 0, but because you
What happens if 0 is 1?
Yeah,
you show the work, or right now, maybe
sure.
What about the 0? What would it be if the 0 was 1?
Yeah, so she's showing the work for how.
Oh, you're fine.
Okay. Thank you, yeah, that's, I see.
After, since we're down from last time, I go down to that you can help now.
Yeah.
I think we can help each other.
Okay. So 1 is the average value. And at what point? So we're going to set 1 equal to the original. So in other words, when we want to figure out at what x value, we go back. Remember I told you that the average value was a y value. So if we go back here and let f of x equal 1, so we want to solve this equation, 1 equals 4 minus x squared. So x squared equals 3. Now, this would imply that x would equal plus or minus root 3, but we don't want the negative. Why not? Good. So look at, well, it could be negative, but look at your integral, or your bounds, excuse me. It went from 0 to 3. Is negative root 3 in that integral? No way. So we just want the positive part. Okay, so if you have to take the square root, for example, you really do get 2 solutions. So you have to go back and look at your domain and figure out which one is in the domain. Sometimes it could be more than one. Notice I put in here in parentheses, I did put points. It could be more than one place. Okay. So this just summarizes it. That's just the mean value theorem. We just did that.